All right, so let's talk about what are we going to do with the data that we collected. How is it going to look, and how do we analyze it to make some inferences, some analysis of that data. So let's go to that example. Let me give you an example again. Let's set up the study, a scenario. Let's say you did a study where you were going to rate performance on a scale of an interval scale from 0 to 100. And you've got two groups flying a cross-country scenario that, is, let's say, through a mountainous terrain. And the two groups that you're looking at is one group will get GPS, highly advanced GPS, and let's say the other group will get no GPS. Right? So we have two groups, and we're going to look at, let's say, their performance with the GPS versus no GPS. Now, there's two ways we can approach this study, and depending on how I helped you out, you would either have done what's called, there's two ways to look at it. Between groups versus a paired test. What that means is a between two groups test is you would have two groups of people, two groups of pilots. One group of pilots in one corner will get the GPS version. The other group of pilots will get the no GPS version. Some of you will be doing a paired test, and there's a different process to do a paired test where you're using the same group of people, but you're giving them two tests. One test with the GPS, you're going to give them some time in between that test, and then they're going to get the same test, same person, but without a GPS, and you're going to rate the performance. There are a lot of elements to this that is not discussed in this class because it's not a full research class, but there are some things you'll have to think about and some assumptions that you'll have to take care of with respect to that scenario. However, to keep things simple, let's say we're doing a paired test, same group of people between GPS and no GPS. And actually, let me go back a little bit. And instead of making this this performance would be an interval test, a 0 to 100, kind of like a thermometer, right? It has a scale with respect to 0 to 100 in that sense. Let's make this what we would call an ordinal scale, kind of like what a lot of you are doing, and we'll call this the instead of performance, let's use the variable of willingness to fly, like a lot of you are doing that. So we might as well and that's ordinal in the sense that you're using a Likert scale, right? From -3 -3 to +3, let's say, or 0 to 5, right? That's a Likert scale. And that's ordinal because it's not necessarily 0 to 100 graded in that sense of a scale. And so we'll use an ordinal scale, and that will determine what type of test you will do. And we're doing a paired test, so we're not doing between groups. And there's different ways to approach this. If you did between groups, it would be a different process. So now we're doing a paired test with an ordinal scale of willingness to fly with the same cross-country, but with one airplane with GPS and the other airplane without a GPS. And let's say I did the survey and I collected the results, and the average Likert scale willingness to fly with the GPS was pretty high. Let's say the average score out of a 0 to 5 Likert scale was a 4. And for the particular cross-country scenario without the GPS, the Likert scale was, let's say, a 1. Okay. And with that said, now we want to say, hey, is there a difference? Well, visually I can say, well, there's a difference. In general, most of my participants are not willing to fly without a GPS. That's got a lower score overall than a GPS score. This is the basic descriptive statistics. So on average, the GPS score is higher than the no GPS score. Well, we want to also do some statistical analysis to see if there is an actual statistical difference. Is there a significant difference? Is this number, is this change from here to here statistically significant? And there are different tests that are out there, and we talked about a t-test before, but if we're doing an ordinal scale, that's a paired test, you'll do something similar to a t-test, but it's called the Wilcoxon test. It's going to measure the statistical difference between two averages of two tests between the same group, within the same group, excuse me. So the same people, but two different tests, and we're measuring the differences between the two average scores of that scale, and we're going to see if there's a significant difference between the two. So let me go over it. So let's say I created my study. This is my flight survey in Google Forms that I showed you guys to do, and we'll run through it. So let's say I'm a participant, right? And I run through this, and I'm given a scenario. I haven't written one here, but let's just say I'm given the cross country, given the data, and said, all right, you are given here in this scenario the GPS, right? And so you now are going to rate this scale. Say, okay, this is how I feel about that willingness to fly. Then in this second scenario, I'm changing it slightly, giving some extra information, or maybe it's saying now there's no GPS in this one, and let's say I'm not as willing to fly in this scenario, and I rate my scale accordingly, right? And I hit next, and I provide my information accordingly for all this information, and I hit submit, right? Let's say we made it where they have to submit that. All right, so that was the participant view, and let's say now I am the analyst, I am the researcher, and I go to my Google Forms. Hopefully you'll have more than 4, and we'll click on this, and we say, okay, now I want to download the responses. So if I download the responses, let's take a look at it. Boom, it would look something like this, and I only got 4 responses. Hopefully we'll get a bunch more. We get like a bunch more of responses. And so I can take this off. I basically, if any of them said no, they shouldn't get any scores, so that should be the case. And make sure that they all say yes, and we'll delete this. And now what I've done is, let's say I'd provide the age. I'd have some information in these cells as well, but for the time being I'm going to move this because I'm not going to pay attention to that for the time being. So these were the scales, right? And I know that based off my data there were 3 questions for each scenario. So this is scenario 1 and this is scenario 2. So what I'm going to do is I'm going to insert some rows here. And I can, let's say, wrap the text so it looks kind of like this. All right, so this is scenario 1, and this is scenario 2, right? And if you want, you can even label this scenario, and we'll call this scenario 1. Copy that, and 2, copy that. Goes all the way down. Okay, so that's scenario 2. And what I want to do now is say, okay, this is one individual. I want to know this individual's average score, because that's the score for the willingness to fly scale. So we'll take the average score. And helps if you spell correctly. There you go. Copy that because that's the Excel formula. Hit paste, and now I have average scores of these individuals, and I'd continue that all the way down for the number of participants from scenario 1. And let's make this 2 decimal places so it's a little bit easier to deal with. And I like to highlight this as red, so I know that this is the average scores for the individual for the willingness to fly for scenario 1. I do the same thing for scenario 2. So now I have the average scores for scenario 1 and the average scores for scenario 2. If I wanted to make a quick graph, I can make an aggregate average of these guys, of the full of scenario 1, and the aggregate average for scenario 2. And now I can see the aggregate average between the two, right? That's basically my graph that I showed you on the iPad. So it's 3.75 and 1.83. Now if we were doing, you would also want to do the standard deviation and the standard error. And I'll probably have to explain that in another video so we can do the proper bar charts. So that it can show the differences between the two. But for right now, let's just focus on this. And so we've got a little graph here, and you can use Excel's functions of inserting a chart. And actually, we don't need to do that because it's going to get confused with the numbers here. So we'll just put that and plug in the charts. I just need that information. Boom, there you go. That's the difference between scenario 1 and scenario 2. And so what I can do is change the colors too. If you're not familiar with that, I double click on the bar and you can change scenario 2 to be a different color so it's easier to look at. And you can change the title. So we'll call this let's try that again. You can do it that way. So selecting specific data points, hitting the chart. That should, yep, there you go. Scenario 1, scenario 2. Take that off, we don't need that. And change that to the color so it just looks a little bit more fancy. Oh, let's change that to blue separately. There you go. So now we have let's say GPS versus no GPS, right? So now we have a chart we could use for our study, right? And we can actually call scenario 1, let's say GPS, and then no GPS. And that will probably be a little bit more reasonable in terms of scenario 1 versus scenario 2 to quickly look at it. Well, just by looking at this, we can make an assumption or make an inference that people will prefer flying or more willing to fly, pilots would be more willing to fly with the GPS versus no GPS. That's great. However, that doesn't give us any statistical analysis other than this is descriptive and this is just basic averages between the two. So now we have to do what's called the Wilcoxon statistical test. And in order to do that, you need to have a statistical piece of software, which is called, we have access to something called SPSS. So if you type in SPSS in UAA's website and go to the software, students actually have free access to this software tool, and you can follow the instructions here. It's a little cumbersome, and we only need it for a couple weeks. So when you're ready, I would go to, or this week, because I'll give you a couple exercises to practice. You can go to ibm.com or just Google SPSS and then try the free trial for 30 days. It's basically October 26th, so in a month we should be done with our study. So you're welcome to do it that way. It's a little easier. Faculty have access to SPSS, but for the time being we can do until we're ready to have this a little bit more streamlined for the statistics portion to download it for students, you can try and follow it with the UAA website, but this one's also free for 30 days for you to try it out. So we've now got the Excel sheet. What I do is if you take a look at it here, I started working a little bit on it. Let's create a new data with SPSS. So it'll look like this, right? And we want to go to data view, and now we have variables, variable columns. It's a little bit different than Excel. So what I want to do is copy and paste under this column, variable 1, the average scores from scenario 1. That's going to be called the scenario 1 average scores. So I'm going to paste that over here. And then I'm going to do the same thing for scenario 2. Paste that over there. I now need to describe them. So this was willingness to fly 1. We'll call that scenario 1. So I'll just label that so that I can follow. Willingness to fly scenario 2. We know that it's numeric. Those are the numbers, right? However, the measure is ordinal. They're both ordinal measures, all right? So they're on a Likert scale. They're not a graded 0 to 100 scale or percentage scale or a thermometer scale. They're not interval. So they don't fall under nominal or scale. They fall under ordinal. So these are both ordinal. Anytime you use a Likert scale, they're ordinal. Okay, so we've got that. And what we want to do is analyze it using a Wilcoxon test. So if we go to Analyze on the top, you may not see it, but on the top bar there's a title that says Analyze, and this bar will come down. And you want to go, these are all the different statistical analysis you could do with data, and we're kind of keeping it simple for this test. And we go to non-parametric tests. Now the reason why we do non-parametric tests is because it's a Likert scale. And we go to legacy dialogues in this case, and we do what's called a 2 related samples. They're related. They're samples from 2 of the same group. So this is where we go here. We click on that. And we bring these 2 data columns into the study right here. That's the pair, right? And we're doing a Wilcoxon test type. Then we hit OK. And this will populate from your results. And this is what we're really interested in here, is the test statistics, the z-value and the two-tailed value, because we want to look at this number, and basically if it's below 0.05, then that means it's got a statistical significant test. Okay, there's a lot going on, right? This is not a full research course grad level, so I'm not going to go into that much detail. I'm going to simplify a few things here. Why are we looking for that number? Well, I recommend Laird Statistics is awesome. This place, if you just Google Laird Statistics, and they have all the different tests and examples of how to analyze it, how to set it up, why you would do some specific test. So Wilcoxon signed rank test is a non-parametric test equivalent to a dependent t-test. Remember, we talked about t-tests. So a t-test would be something that would be used for an interval. It's very similar in this case. And so here's an example. You could use a Wilcoxon test to see if there's a difference in smokers' daily cigarette consumption before and after a 6-week hypnotherapy program in that case. So there's a before and after, but with the same person. They're related groups. Right? And so you want to see if there's a difference in reaction times under 2 different lighting conditions, right? So you're looking at, oh sorry, this is a different test. Looking at the difference between cigarettes before and after, using cigarettes before and after a hypnotherapy program. So we're looking at the same group, GPS versus no GPS, right? And these are all the assumptions. These are all the things I would go over in a statistical course, a statistics course, or a full-on research course to really examine a strong study. So these are all the different assumptions that we have to consider and check and make sure our data follows these assumptions. Again, one of the assumptions is an ordinal ordinal variables include Likert items, which is what we have. So you can see one of those there. So you can read this. And I showed you how to do the analysis on SPSS, right? And here's where it gets pretty good, where it tells you what the output actually means. So I use this quite a bit just to make sure I'm following the right steps. And we want to go right into the test statistics table. And so below 0.05, our goal is to reach a p-value of 0.05. I'll explain what a p-value is in a second. So when we report this, this is what you're going to report for your study. A Wilcoxon sign rank test showed that a study regarding the use of a GPS versus no GPS in a cross-country plan did not elicit, if it's above 0.05, it'd be, the term would say did not elicit versus it did elicit a statistical significant difference, or change in this case, difference in pilot's decision to for willingness to fly, brackets z equals whatever the score is over here for your z-score, and then p equals, this is your p-score, your probability score with respect to that. Alright, what did I mean with all that? So we got somewhere here where we've got quite a bit going on. So we've got to interpret what this p.05, you'll see in a lot of studies, two values, 0.05 and 0.01. You determine this a priori. What this means is you determine what your p-value will be before you study. And most of the time I'll recommend most students to say, hey, we're going to use 0.05 as our statistical analysis value, our p-value, okay? So in terms of p-value, we first have to talk about the null hypothesis and the alternative hypothesis, right? So if we remember, we came up with two hypotheses. The null hypothesis is that there is no difference. There is no difference between people's choices to either use GPS or willingness to fly using GPS or without GPS, right? So let me bring back up my... So we're saying the null hypothesis would mean before I collected this data, before I made a decision, I'd say that these bars would be almost the same. There's no statistical difference. The alternative hypothesis is that there is a difference, positive or negative. It doesn't matter. Let's just keep it simple and say there is a difference. I'm expecting that there will be a difference between willingness to fly with a GPS versus without a GPS, right? And so what we want to do is say, well, at what level are we willing to say that there was a significant difference? And most of the time we want to have p to be less than 0.05. Well, what does this mean? That means if you run your statistical analysis, this p less than 0.05 means there's a 5% chance or 5% probability that your results basically happen by random chance. Let's say, put it that way, right? So it's saying that there's a lower chance probability. The lower it is, the lower the value from 0.05, the less chance that your result produce a where it was caused by by just randomness in that sense. So another way to look at it is, I had a good explanation here from the website. So if we go to p-values, so in this case, if you had a p-value of 0.03, right, it means that, in this case, this particular example was saying that you've got a medical trial and you're testing two groups, one with the vaccine and one without the vaccine, and seeing if there's a change or fix or interaction, right? And if you got a p-value of 0.03 in terms of the difference between the two groups, that means that if the medicine has no effect in the population as a whole, 3% of studies will obtain the effect observed in your sample, or larger because of random sample error. So what that says is, what the p-value is answering is how probable are your sample data if the null hypothesis is correct. So the null hypothesis is there is no difference. So what is the probability that your sample was should be with the null hypothesis that there is no effect? So that means that if my value was 5%, that's 5% of my sample data, 5% probability that my sample data should have had no effect, right? In the case, it's not about error rate, but in the case of the statistics here, it's saying that 6.8% of my data, my sample size shows that would have fallen under, if I were to take 6 out of 100 people, it should have shown no difference, right? And that's basically what it's saying. And we're limiting it to 5%. We want to say if it's less than 5%, it's acceptable. That means that this study was showing that there is a statistical significant difference between the two groups. So if I took 5% of my sample population, yes, there's a probability that my null hypothesis is correct. But that's a lower probability. I'm more willing to accept my results rather than something with a higher value. And that's where we come up with the p-value has to be less than 0.05. Okay? P-values are not an error rate. So what is the possibility that I'm wrong? What is the possibility that I'm wrong? The p-value doesn't tell me this. If I get 3%, doesn't mean like I was 97% correct that there is a significant difference. No, this is where power comes into play, and that's the power of your sampling. And so what we're saying is that we've got to look back at G power. Let me go back here. All right, I'm going to pause right here. My oven's actually going off. 1 second.